Hi guys, welcome to experiment number 6. In this experiment, we're going to determine the Ka of a weak acid. Okay? You're going to start out with a little Eppendorf tube, with a liquid acid in it. It's 100% acid, okay? In its pure form, it's a liquid. So the first thing you're going to do is you're going to get the mass of the tube and the acid. Then we're going to get a mass of the tube after we've emptied the tube into a volumetric flask, and that'll give us the mass of the acid. Then we're going to fill the flask up with water to make our acid solution. Then we're going to pipette in 20 milliliters of the acid into 3 flasks. We're going to measure the pH of the solution, and from the pH you should be able to calculate the hydronium ion concentration. Then we're going to titrate it like we did last experiment to determine the molarity of the acid solution and get an average molarity. Okay? Then we're going to do an ice chart with the average molarity as our initial HA concentration and determine what we'll get is the initial HA concentration, and the pH will tell us the hydronium ion and the A- concentration at equilibrium. Okay, I'll kind of step you through it. And so that's going to be that will allow us to calculate a Ka for the reaction. Then we're going to take it back to half titrated and get the average pH at half titrated will be a second way to calculate the Ka. And then we're going to calculate the molar mass for the acid based on our titration data. And with your Ka and your molar mass, you should be able to determine the acid. Now, we've got a weak acid, HA, okay? And what we're going to do is react it with NaOH. Anytime I react a weak acid, and HA is Joe generic acid, with a strong base, we get 100% conversion to water liquid and Na big A, aqueous. Okay, this goes 100%. So the molarity of the acid times the volume of the acid is going to equal the molarity of the base times the volume of the base. So the molarity of the acid is going to equal molarity of the base, volume of base, over volume of acid. Okay? So the first thing that we're going to be interested in doing is doing a titration to get the molarity of our acid solution. Okay? And we're going to get our pH. So let's go over to our setup and let's get started. First thing we've got to do, okay, is get a mass. So we're going to come across the room here. We're going to play with the balance. Now, this is a balance that reads to 3 places past the decimal. Okay? So I'm going to tear it out so it reads 0. I'm going to put the tube in there with the liquid in it. So our mass of the tube in liquid is 2.516. Okay? Now I'm going to empty the liquid into the volumetric flask. Okay, it's in there, very little, but it's in there. And I'm going to weigh the tube again. So the tube empty is 1.059. The difference between those two is my mass of acid. Okay? Now I'm ready to add water to my flask. Now I'm going to add water fairly quickly to begin with, distilled water. Halfway through, I'm going to swirl it. Okay, I'm getting really close. Now there's an etched line here on the flask I'm going to slowly add water till I get to that etch line. Okay, I'm there. Now I'm going to invert. And it's time for us to walk back to our setup. Okay, here is a pH meter. Okay, now, first thing I have to do with the pH meter is I have to turn it on and calibrate it. Now, this is our pH probe. Okay? So let me kind of spread things around here. I'm going to turn the pH meter on and we're going to calibrate. Now, I'm going to take the pH probe out of its storage solution. I'm going to rinse it off, and then I'm going to dry it off, and then I'm going to put it into a buffer and hit calibrate. Okay, so it's sitting in a buffer solution, a 4.0 buffer solution, and I have the machine calibrating. So it's calibrating off of 1 point. You see it's kind of adjusting its pH. It's kind of going down. Swirling it, make sure that everything gets kind of where it needs to be. I'm going to let that sit and calibrate while I pipette 20 milliliters of the acid solution I just made into Erlenmeyer's like we did last time. Okay, I know it's like watching paint dry, watching the pH meter. It's okay. There. I don't like this pipette bulb. Okay, here's my first sample. Now, pH meter is ready to rock and roll. So now that I've got my first sample titrated out, I'm going to take the pH probe, rinse it off, dry it again. I'm going to put it in that first solution, and we're going to read the pH. Come on, read the pH. Now, as long as the dot is flashing, it's still trying to shuttle in on what the pH should be. Okay? Okay, we're gonna go with 2.86. So the pH of our solution is 2.86. Hydronium ion concentration then will be calculated by taking 10 to the minus 2.86. Okay? Now I'm gonna do my other two pipettings here as quickly as I can. And then we will hit things up with phenolphthalein again. It's one of our favorite indicators. Grabbed a different pipette bulb and see if this one will like me better. Okay, so I'm going to pipette. This pipette bulb is definitely working better. Okay. Ah, shoot. Oh, I'll have to repipette that. Okay, there's one pipetted. Over there for a second. Don't want to spill anything on the camera. Two pipetted. And I'll redo the one that got screwed up. Okay, now once I've got them all pipetted, I'm going to add phenolphthalein just like we did last experiment. And we'll titrate. Okay, so over here we go. And we're going to titrate just like we did last time. Got in there correctly. Okay. Just to be on the safe side. I'm waiting for my pink color to start showing up. Okay, it's showing up gradually, means I'm getting close. Okay, we have hit endpoint. Now our initial burette reading here for run 1 was 0.00. Our final burette reading is 21.90. Okay? So we can do the second one without having to redo. Your initial burette reading for the second one is 21.90, so I'm going to around 42 and slowing down. See how the pink color is getting more persistent? Tells me I'm getting close. I want to slow down. I want to make sure I'm swirling. Now we got a really pretty faint pink. Maybe one more. No, that's still staying pink. Very pale. This time my burette is reading 43.6. So 43.60. For the third run, I'm going to have to refill. So I'm going back to up to the top. Fill her up. Okay, NaOH. My bottles of NaOH. Okay, let's go for this last one. Okay, our initial burette reading is 0 again. I know I can go down pretty quick in the neighborhood of 21 and then go from there. I know, we're having to wait, but patience is a virtue. You can do it. I'm just videoing the lab.
I'm sorry.
That's okay.
I had a quick question on my grade. The mastering grade that I put in, like you put in, was like a lot lower than I expected it to be.
Let me turn this off and we'll go down and look.
Okay, thank you. Sorry to bother you. I didn't know.
That's
that was
okay.
the video.
Okay guys, through the magic of the camera, I have done titration 3 without you having to watch the whole thing. And my burette is reading 22.2. 22.20. So you should have a data table that looks like this. Initial burette reading, final burette reading for runs 1, 2, and 3. And you should then be able to calculate your molars of base by just taking the difference and calculate the molarity of the acid given the molarity of the base. Now let me give you the molarity of the base so that you have it to calculate. So give me just a sec here. I have to look it up. it's the molarity of your base is going to be 0.94 molar. Okay, so use that molarity, that equation to calculate the molarity of your acid. Okay, now we're going to get, so if you look here, the pH is going to give you your initial concentration. You get this from pH. This initially is 0, that initially is 0. So it's plus X, whatever this is, minus X. X is going to equal 10 to the minus pH. So you're going to put that in here and here and subtract it from that to get that, and you're going to be able to calculate your Ka. Okay? Now we're going to add acid back to our containers here, and then we're going to measure the pH again. $20 mils of acid back. This takes us to half titrated. One. Okay, let's get the second one. Pipette. Okay, and it always goes through small through the bubble, really slow when we go through the bubble in the middle. Okay. Our second one to half titrated. Notice how the pink color is disappearing as I add the acid back in. Now, we are playing with a weak acid here, not a strong acid. When we go back to what's called the half titrated point, okay, the pH at half titrated equals the pKa. And the Ka then is 10 to the minus pKa. So we're going to have a very convenient way, a second method to calculate the Ka for our acid. Okay? All right, in we go. All right, now we're back to our pH meter. Make sure everything's looking good there. Okay, there's our pH meter all set up. Okay, I'm going to take the probe out of the buffer solution, wipe it down again. Okay. I am going to put it in our solution here, okay? I'm going to hit read. Okay, it should be reading. Give it a little bit to sit there. I want that to get stable. So the pH at half titrated for our first flask is 4.63. Okay, I'm gonna move it to the second flask. I'm getting 4.62, well, 4.61. And I'm gonna move it to the last flask. And I'm getting 4.63 again. Okay guys, now we have our data. So the first page of your lab should have this data on it. Okay? You're going to figure out the rest. The second page now should have the pH at those three, for those three flasks. Now let's go to the board and look at things for a second. Okay? Now, that's how you're going to calculate the molarity of your acid solution. And for part 2, okay, your Ka is going to equal the negative log, it's going to equal 10 to the minus pH here at half titrated. Now, you're going to have two Ka values, a Ka from part 1 and a Ka from part 2. Average those. Okay? And you're going to compare them against some known acids. So let me give you some known acids here and let you figure out what your acid is. Okay, I'm pulling my book out from underneath you so that I can look at the Ka values. Okay, come on, Ka table. Okay, you could have the following acids. It's going to be your job to identify them. You could have HCN. It has a Ka value. HCN, come on. 4.0 times 10 to the minus 10. You could have carbonic acid. It has a Ka of 4.2 times 10 to the minus 7. You could have acetic acid. And it has a Ka of 1.8 times 10 to the minus 5. Okay, so those are your three choices. Now for each one of those, you're also going to be calculating its molar mass based on the mass of the acid that you weighed out and the molarity of your solution that you got through titration. The molar mass for HCN is 27.03 grams per mole. Carbonic acid has a molar mass of 62.03 grams per mole, and acetic acid has a molar mass of 60.52 grams per mole. So between the molar masses and the Ka combinations, you ought to be able to determine which acid you have. So on your final lab report, you have to tell me which acid you've got. HCN, carbonic acid, or acetic acid. Okay? Molar mass here will definitely, give you a dividing line between hydrocyanic acid and carbonic acid and acetic acid.